Hi again. Alright, so we're going to talk about another new concept, this time kinetic energy, but you might notice I left potential energy up on the board, and you'll see why in a moment. So let's take a different example. Instead of a bowling ball falling off a bookshelf, how about we take a gun firing a bullet? So here is the gun, and it has a bullet in the chamber, and there's gunpowder behind it, so there's lots of potential energy here. This bullet, if we fire it, pull the trigger, will do work. A force will be applied and this bullet will move a distance. So, pull the trigger, the bullet goes out, it's now moving very quickly. Alright, it's no longer in here. So there's no more potential energy. But there kind of is, because potential energy says the ability to do work. And this moving bullet could still do work. Let's say it hit a block of wood over here that was just sitting on a table. Well, when this bullet hits the block of wood, it's going to get embedded into it. It's going to move the block of wood. To move that block of wood, it must have applied a force. It must have done work. So there's kind of like there's potential energy embedded in this moving object as well. Now, we're going to use a different phrase for this, a different term, because we like to think of potential energy as not just the ability to do work, but a stored ability to do work. We're going to use a new term called kinetic energy. And this is going to be basically the same thing, still ability to do work, but really all we're saying now is that it's in motion. That energy is being used for something. So, potential energy, stored ability to do work. Kinetic energy, we're going to call the energy of motion. But really it means the same thing. It just means, I could do work. If I'm running full speed and I run into something, it's going to move. Alright, so I put that energy, this morning I woke up, I had breakfast, now I have stored energy inside me. I have the potential to do some work today. And some of the work I might do is push really hard on the ground to get up to speed, run really fast. Well, I've converted that potential energy of my breakfast, which is always a Big Mac. It's a good way to start the day. So I took that Big Mac, I converted it into running, mechanical energy. I'm moving. I now have kinetic energy. But if I ran into a person, I would end up pushing them and knocking them over. So I'm doing more work. Kinetic energy, we're going to have to quantify a little bit different. So I'm not going to go through how it's derived right now, but kinetic energy is 1/2 mv squared. Now you might be looking at this formula, and you might be looking at the definition and say, hey, this seems really similar to that other new term we came up with recently called public momentum. If you remember, momentum, which we symbolize as the lowercase p, is equal to mass times velocity. In fact, these are very related. If you were able to do a little bit of calculus, you would say, oh, if I differentiate this equation, I get that equation. If you don't know what that means, then don't worry. So we're going to find out that not only are these two things similar, but that we're going to end up using them quite a bit. Now, momentum says that if I'm a moving object, if I have mass and I'm moving, I want to keep moving, and this is kind of a measure of how much. And kinetic energy says almost the same thing, but it just measures it a little bit differently. And we'll see kind of how as we actually play some problems out and work through them a little bit. So right now we have potential energy, kinetic energy, momentum, and then also you have work, which is W equals force times distance. Those are all the terms and all the things we're going to work with in Unit 7. So if you feel comfortable with these, you're in good shape. There's going to be another couple videos with sample problems that are specific to how these things interact. So for instance, taking potential energy, using it to do work in order to convert to kinetic energy. Or when things collide, there's a lot going on there. There's forces when they hit each other. They transfer momentum, but they also transfer some kinetic energy. And sometimes in the process do work. So we'll look at some of those problems as well. But that's a quick overview of all the terms and all the formulas we'll be using in Unit 7. Bye now.